Today we're going to be covering section 2.4, which is solving linear equations. And really it's kind of a roll-up of section 1, 2, and 3 that we've already done. When we have basically any of our linear equations, and we're just focusing on linear equations right now, and the key word here at linear means it makes a solid line when you graph it out, and we'll kind of get to graphing a little bit later. But basically for our linear equations, all right, up to this point, what we've been trying to do is solve them. And that's still what we're going to do. But anyway, these are just your steps to solving linear equation, and we kind of went over them already. So this, like I said, this is kind of going back over that. But basically, the first step is you're going to use distributive property. And the key to that is you're going to use the distributive property to separate the terms. And what are those terms? Well, basically, what it's saying is if you have fractions, then you'd want to clear those fractions first. If you had decimals, you'd want to clear those decimals first. I'll kind of show you what I mean by that as we move through the section. So number 2 is going to be what we covered in section 2.2, which is the addition property. I'm just going to abbreviate that, of equality. And basically remember that basically boils down to a simple step. Letters one side, and basically your numbers on the other. Right? Letters on one side, numbers on the other. Keep saying that over and over. Then number 3 is going to be our multiplication property of equality. And that was the section that we kind of just went over, which was section 2.3. Just going to abbreviate property here. And that is basically using your reciprocal. Reciprocals keep coming up over and over, not just in these sections, but other ones as well. And then the last one says check your solution. And the caveat to checking your solution is if it's applicable. And what I mean by that is if you have a lot of fractions to go back through, I wouldn't go back through and work all those fractions out again. Just trust your work. So those are basically your 4 steps that we're going to use to solve any of our equations. Some allow us to skip over because if we only have letters already on one side and numbers on the other, we can kind of skip this first one. If we don't have any fractions, then we can kind of skip that one. If we only have a single x, then we can kind of skip this multiplication property of equality. And then if we have fractions, we can kind of skip this one. But these are your basic setups to solving any of the linear equations. And once we go to graphing these, which is later, you can kind of see how they make lines. So we're just going to start out with one for an example that looks like this. It's 2x plus 3 is equal to 10. Now, because this is in the parentheses and we're not evaluating, so we don't know what x is, we're trying to solve for that. Remember, when we do the distributive property, everything outside the parentheses times everything inside the parentheses. So basically, this is going to be 2 times x, which is going to be 2x. This is going to be 2 times 3, which is going to be 6. And then equals 10 just comes down. So that's what I mean by the distributive property. So there's no fractions in this one. There's no decimal, so I don't have to worry about that. So now I can go to the addition property of equality. Numbers on one side, letters on the other. So this is a positive 6. So I use negative 6. Whatever I do on one side of the equation, do on the other side of the equation. That allows that to disappear. My 2x just basically falls down. 10 minus 6 is going to give me 4. And the addition property of equality goes to the multiplication property of equality, which is basically our solution. Right? That's kind of almost our last step other than solving that. But anyway, this allows you to come down to a single x. 4 divided by 2 is 2. And that's our answer. Now, it's pretty easy to go back up and check this because we don't have fractions. So anyway, I'm just going to rewrite this linear equation over. I'm going to substitute the 2 in here. So that's going to be 2 times 2 plus 3. Because I can go ahead and simplify that and condense all this down to one number, 2 plus 3 is going to give me 5. 2 times 5 is going to give me 10. And I know that 10 equals 10, so that tells me that that one is correct. Now, if I'm substituting these in, I would be evaluating, but for these linear equations, I'm going to use another example, and let's say that I'm just using 3 times x minus 4, and I'm going to use this, let's see, plus 6 is equal to 9. So you're going to see someone similar to this on your test. Same process is going to be used. Remember, everything outside the parentheses times everything inside the parentheses. Now you can write these out, but it's real easy just to kind of multiply these straight across, but whatever works for you. 3 times x is going to give you 3x. I have a positive and a negative, so I know this is going to be a negative. 3 times 4 is 12. This is outside the parentheses, so that just kind of drops down. Now, I'm going to go ahead and simplify. I have a negative and a positive here. I'm going to still use my two-step process because I could move these over one at a time, but it's easier just to kind of condense these. Negative and a positive, they don't match, so I subtract. 12 minus 6 is 6. 12 is bigger, it's a negative, so this is going to be 3x minus 6 equals to 9. It's a negative 6, so to move it, I have to add 6. Whatever I do on one side of the equation, do on the other side. That allows my numbers to disappear, so I'm left with 3x is equal to 15. Once again, divide these both by 3. That allows this to become your single x. 15 divided by 3 is going to give me a 5. Now I can go and put this back in. Once again, this is 3. I'm just going to substitute in this 5 here. That's going to be 3 times 5 minus 4 plus 6. And we're going to see if all this equals back up to 9. So 5 minus 4 is 1. 3 times 1 is 3. 3 plus 6 is going to put me back at 9. So I've checked my solution. It's really quick and easy to check those. So it's always best if you check them. Once again, if you had fractions, maybe not the best way to kind of go back and check them. Now, occasionally you're going to have decimals. Decimals seem to throw people off, and those of you who are going to be business majors, you're going to see a lot of decimals moving forward. And I don't mean in this class, but I mean we have them. But for your business classes, it's going to use a lot of decimals and a lot of percentages. So if I'm having decimals, so for an example, this is 0.4, and generally I would try to put a 0 in front of that so you can tell that this is a point here, so there's no confusion. So if this is .x plus 0.05 or 0.5, and all of that is going to be equal to, oh, I don't know, let's just say 0.2x, and all of that is going to be, let's say minus 0.3. So I have x's, I have my variables, and then I have my constants or my numbers. So I'm going to solve this just like with everything else. Now, the easiest thing to do is remove all the decimals. And what I mean by that is, remember, through the multiplication of property of equality, I can multiply this entire thing by 10. And what that does, it allows you to move all your decimal points one spot. So this 4/10, or basically 0.4x becomes 4x. This 5.5 becomes a 5. This 0.02 or 0.2 becomes a 2x. And this becomes just 3. Now, if these had regular numbers in there, and we're not going to solve this right now, I'm just showing you the example. So if I had 2x plus, oh, I don't know, let's say 0.4, and let's say I had 4x here minus 0.2x. Once again, I have whole numbers, and now I have decimals. It's still easier to remove all the decimals by multiplying this entire thing by 10. And then what that does is this turns 2 times 10. This is just going to make this 20x. This is just going to basically still move everything one to the right. And when it does that, these just fill in with zeros. So this becomes a 4. This becomes a 4x to a 40x. And this just becomes a 2. So these are the exact same equations, right? Because anytime I multiply these, they stay the same. So I am going to solve this one just to kind of work it out. So anyway, letters on one side, numbers on the other. I'll subtract 40x on this side, whatever I do on one side, do on the other side. Then I'm going to move the 4 to the other side, so that's going to be the opposite of positive 4, which is going to be negative 4. Once I have these set up, remember this is just going to allow those to disappear. I have a positive and a negative, so I'll subtract 40 minus 20 is going to be 20. The 40 is bigger and it's negative, so that's going to give me a negative 20x on this side. These two sides match, so I add them. 2 plus 4 is 6. 4 is bigger, it's a negative. So this is what this one's going to kind of break down to. I'm going to subtract both of them by a negative 20, because remember, if your variable is a negative, then you have to divide it by a negative. Whatever I do on one side, do on the other. Now remember, two negatives divided by each other gives you a positive. Same thing on this side. If I have two negatives, they match, so this is going to be a positive 6 over 20. And then I'll see if this will break down or factor down into my magic numbers of 2, 3, and 5. And it will. Both of those are divisible by 2. So this becomes 3 over 5, and this will be my final answer. So obviously this would be one of the harder ones that you would come up with.